This problem is not a verification of an identity. It's not an equation. It just asks us to take this expression and write in terms of sign only. So sometimes we want an expression that just has one trig function in it. So here's an example. So we can write, since we're going to be using sine, we can write tangent in terms of sine and cosine. That's the reciprocal identity. But secant theta, we can't write it in terms of sine, but we can write it in terms of cosine. So we're going to use a reciprocal, did I say quotient identity for the first one? Anyway, I hope I did. And then the secant theta is going to be the reciprocal identity, so it's going to be 1 over cosine theta. And while we still have cosines in our expression, it's going to be okay. So you can't trade a cosine for a sine, and you can't trade a sine for a cosine, but you can trade a cosine squared. So we're going to take that 2 sine theta in the numerator and write it over cosine squared theta. That allows us to use the Pythagorean identities. So now we can write it as 2 sine theta over 1 minus cosine, or I'm sorry, 1 minus sine squared theta. And then that's in terms of sine, and we're good, okay? And then we have this last one. So this one involves a process that's used, and sometimes students don't always just think of it, but we want to get the left-hand side to look like the right-hand side. And again, we're stuck with just cosines and sines here. So how do we know which side's more complicated? Well, that's kind of a decision you have to make. I'm going to say that the right-hand side is in a better form, more simple, because it only has one term in the denominator, but you could easily get, just as easily get the right-hand side to look like the left-hand side. I'm not going to do that, though. I'm going to work on the left-hand side. So I'm going to take my cosine theta over 1 plus sine theta, and I'm going to multiply by the conjugate of the denominator, which is 1 minus sine theta. And that's the part where, you know, I don't know if it screams out to you to do that. Kind of have to think about it a little bit. And the idea is, well, maybe then we're going, because we have conjugates, maybe we'll get some squareds that we can work with a little bit. And we're going to. Also, notice that now in our numerator, we have the piece that's the numerator on the right-hand side. So that looks very friendly to us. We still have a cosine theta, but it's going to be okay. So cosine theta times 1 minus sine theta. And then in the denominator, you have those conjugates, so it's going to multiply to be 1 minus sine squared theta. But the 1 minus sine squared theta, that we can replace. And so we're going to have cosine theta times 1 minus sine theta over cosine squared theta. So we're almost done. Now that cosine theta over cosine squared theta, it's just like having x over x squared. You can cancel one of the cosines, that cosine theta, with one of those. And so it's going to give you a cosine theta down there. So final expression is going to be 1 minus sine theta over cosine theta. And that's what we had on the right-hand side. And we're done.